Hi everyone. In this video I am going to explain about decade counter and its VHDL code. So decade counter IC number is IC7490. Okay, so IC numbers we have to remember very well because in the examinations you may be asked with especially IC numbers. Okay, by seeing the IC number IC7490 you have to remember this is a decade counter. So 7490 is a decade counter. Decade counter is nothing but which counts 10 number of clock pulses. Counts 10 number of clock pulses. So 10 clock pulses it counts. 10 clock pulses are nothing but the count starts from 0 and goes up to 9. Whenever the 10th clock pulse occurred, automatically the count resets to 0. Okay, so every time it counts from 0 to 9. So in the IC number also, if you observe clearly, IC number is 7490. So just by heart like this, 7490, the count goes from 0 to 9. 7490, the counter counts from 0 to 9. Nothing but it is decade counter. Okay, in that way also you can remember. Okay, so the counter counts from 4 zeros. So 9 is nothing but we have 4-bit number. We have 4-bit number. So 4-bit number we need 4 flip-flops. We need 4 flip-flops. So the count initially the 4 flip-flops are reset. The output is 4 zeros and it goes 0 0 0 1. Whenever new clock pulse occurs, a rising clock occurs. So the count incremented by 1 and again this goes to 0 0 1 0. For every new clock pulse, the count will be incremented by 1. 0 0 1 1, 0 1 0 0, 0 1 0 1, 0 1 1 0, 0 triple 1, 1 triple 0. So next 1 0 0 1 after that. So for the new clock again for the next clock pulse it goes to zeros. So the arrow indicates simply for every clock occurrence. Here I have taken rising clock, that means changing from 0 to 1. Okay, raising edge. It may be considered for the falling edge also, depends upon the type of the flip-flop. Okay, so 7490 IC representation of 7490. So here we have input 1, R1, R2, these two pins are used for resetting, R1, R2, R3, R4. QA, and this is input 2, QB, QC and QD. Okay, so the reset pins will reset whenever the 4 outputs QA, QB, QC, QD are ones. Automatically the count reset to zeros and this process will be repeated. Okay, input 1, input 2 are nothing but clock signals. Input 1, input 2 are nothing but clock signal. You can also represent it as clock 0 or clock 1, clock 2. Okay, now let us see the VHDL code for this one. VHDL code for decade counter. So first, every VHDL code starts with library IEEE use IEEE dot std underscore logic underscore 1164 dot all. Okay, these two statements are common for any VHDL code. And remaining two lines like use IEEE std logic arithmetic dot all unsigned dot all, that though those two we can add in the program, depends upon the usage. Okay, if you are performing any arithmetical operations, then we can go for the unsigned dot all. Okay, so depends upon the usage, we can add those two lines. Next, entity decade counter. Entity decade counter, don't give space. If you want to separate them, use underscore. Decade counter is port of reset pin, clock, reset clock with input direction standard logic and D in out std underscore logic underscore vector of 3 down to 0 for 4-bit data, 3 down to 0. So we have taken clock signal reset pin. So clock signal is used to change the state or for incrementing each state, and reset is to reset all the flip-flops in the beginning state, or whenever you want to reset all the pins to zeros, then you can use this pin. And D is acting as either input or output. See here, there are generally three different directions. We have input direction, output direction, and in-out direction. Okay, input direction means only that pin, that port specifies with input mode is used only for the input pins. Okay, that means those pins must be operated on the right hand side. And output side, output direction is nothing but on the left hand side. Suppose if y is equal to x1 and x2, if I am writing like this, x1 x2 are the input directions, okay, which are used on the right hand side and performing some operations. Those are input directions. On the left hand side, whatever we have specified and assigned with some operation, that is nothing but output direction. Okay, suppose if it is the case, and in the next line we are writing like z is equal to y and x2. I am writing like this. Then y here it is acting as input here, and y here it is acting in output. So y acts in both the directions. One time it is acting as input and one time it is acting as output. So in such case we have to represent y as in out direction. Y as in out direction. Okay, so this is the meaning of D here. D is also considered as in out and decade counter. Now the most important part of the program, architecture. Behavior of decade counter is begin, process. So whenever the process comes, we can easily say that it is a behavioral model of the VHDL code. Reset, clock, and D. Process begin if reset is equal to 1, then what happens? D is assigned with all 4 zeros. Okay, D is assigned with all 4 zeros. So whenever reset pin is activated, First we are clearing all the flip-flops. Resetting is nothing but clearing. Else if rising edge of the clock, rising edge of the clock, then what happens? D initially 0, now it will be incremented by 1. So D is equal to D plus 1. D is equal to D plus 1. See, here we are performing incremented operation. So if now up to what we have to increase? Up to 9, 0 to 9. Once the D value reaches 9, again the output sets to 0. That's why when D is equal to 1001, nothing but 9, then D should be again assigned with 4 zeros. So D will become 4 zeros. D will be assigned with 4 zeros in two cases: whenever reset pin is activated, another one when D goes to 9. Okay, so and if for this if, and one more if is there, and if. After that, so process is there and architecture is there. So end process, end behavioral. Okay, see here once again I am discussing. So process, we have taken process reset clock D, and if reset is activated, reset is 1, then D is equal to all zeros. All the flip-flops outputs are zeros. Else for every rising edge of the clock signal, D is incremented by 1. This is incrementing. D is incremented by 1, and this goes up to 9. So whenever 9 occurred in the output of the counter, so automatically again reset will be occurred for the next clock pulse. Okay, this is what the VHDL code of the decade counter 7490.